Hello. Welcome, everybody. For Chicago JavaScript. I am Justin Love, and I'm also greatly assisted by Jankar, who actually does a lot of the back-end organizing and coordinating with speakers and locations and everything else. So it's a great help to me. And then, did everybody get something to eat and drink? We got food there? Yeah? Let's give you an open hand for providing that. They get the food, they provide the space, they set up the space, they clean up the space. It's extremely helpful to us. And you want to say something, Nova?
Hello, everyone. Welcome. My name is Mike. I've been here about 4 or 5 months or so, so I'm relatively new, but a big JavaScript guy. If you guys are interested in any opportunities I know where we have a newsletter, you can sign up via this iPad, so feel free to go up at any point and sign up. Yeah, that's about it. Welcome.
All right. Cool. Thank you. All right. And I think, is Karl ready, or is he? I'm there. Right. Yeah, you know you're behind me.
Yeah.
All right. Well, we got a stick bytecode interpreters into virtual machines in browsers somewhere. All kinds of levels of stuff.
Right.
Yeah. All right. Take it away. Karl. Awesome. Thanks, Justin.
Okay, cool. So this is my first time giving this particular edition of this talk. So bear with me if there's any rocky points. And if you have questions, I would love to hear them. Just raise your hand. I'll try to keep an eye out. If you see somebody raise their hand and I miss them, do a little yell or point at them or whatever. How many of y'all have worked with Docker at all? What's the familiarity level here? Okay. So we got maybe 25% or less, actually worked with it. How many of you have a passing familiarity with what it is? You could maybe define it if I asked you. Even fewer people? That doesn't make sense. Okay, so my name's Karl. I am the CTO and one of 2 engineers at a little company called the Grade Network. We do ed tech stuff. I love ed tech. I've been in it for about 7 years here in Chicago. I'm happy to talk about that side of things if you want to, but we'll do that after. Today, what we are going to talk about is Docker. And so this is, I guess, last year I was at a meetup and John Karl kind of asked a question about, what would people be interested in hearing about? And Docker was one of the top responses. There's a good reason for that. It's pretty popular. It's gotten really popular in the last couple of years, so you hear it a lot. It's really buzzy. But it's also really useful, so hopefully we'll get into some of that. So what we're going to do is quickly just sort of show you what Docker is at a high level and why it's important. I'm going to spend most of the time, though, going step by step through how you set a Docker container system up to actually run a small node application and then eventually a JavaScript front end in Docker. So this is going to be super applied, very hands-on. If you like theoretical talks by, I need to update Docker. If you like theoretical talks, this is not really going to be it. And I'm happy to do some of that later. I'm not really a computer scientist, so that's not my area of expertise. But as a software engineer, I'm pretty good at actually building stuff out of tools that other smart people build. So that's kind of what we're going to do. Uh-oh. I think I disconnected myself here. Okay. So Docker has, I guess, it came out in 2014-ish. It was kind of when the first more stable releases came out. I started using it maybe in 2015, and even then, when I would install it locally and get it running, every minor quote-unquote version update was a breaking change that broke stuff seriously. So it was almost unusable from a dev experience standpoint. But I think around this time, this inflection point starts happening. Maybe it was early 2015 when it really started to take off. The reason for that is that things started to stabilize enough that it was usable on local machines. So this big rise of when people start using Docker the most definitely happens when it gets stable enough to run local. And it's been a continual line of improvement since then as they've gotten the system better to working on actual servers and deploying it, and the tools got better around it. What's interesting too is that I go to a lot of conferences, and one thing I hear a lot of from people working at larger enterprises is that they're jumping on Docker almost faster than a lot of smaller startups are. And I think Some of that is because it's easier in some ways to port a big existing legacy app to Docker than it is to try to upgrade all your software or all your sort of backend server software up to the latest versions, because you can run any version of backend or server software with Docker, which is pretty handy. So enterprise adoption has gone way up, and that's kind of what this slide is showing. This stuff's from Datadog, which is a server monitoring tool. If you want to look at it, they've got an article that talks more about this. So it's popular, but what is it, right? Let's talk about that. How many of you are familiar with virtual machines? Okay, pretty good number. That's awesome. So with a virtual machine, what you do in practice as an engineer, let's say I want to set up a virtual machine on my local computer. What that means is I'm going to have a whole other version of an operating system running within my operating system, right? Is that square with everybody? It's kind of like at a high level what's happening. So there's a lot of layers to that. There's the actual interface that like works with your hardware, and then there's like a what they call a hypervisor, which is basically going to monitor your VM to keep it running. And then each VM is going to have its own full guest operating system with bins and libs, and then applications running within it. So when you run 3 virtual machines on your local machine, you are going to start stretching your resources. Or you run X number of virtual machines, you're going to start stretching your resources pretty thin. The difference with Docker containers is that you can share the same underlying kernel with your host operating system, and then you use the Docker engine as your kind of like virtualization padding layer there to get some separation between each of your applications. So once again, I'm not super into the computer science of how this works, so if my explanation is not great, go read the docs, because Docker does a really good job with their documentation lately. But that's kind of at a high level how that works. I like to think of this as each virtual machine is going to run like one whole application, whereas each Docker container is going to run one single process. So that is the big distinction, and that's the thing that's hardest to wrap your mind around. So typically when you run a virtual machine and you want to run Node, a database, and Nginx as your web server on it, you're going to have all these things set up. You're going to have some startup scripts that make sure they stay running. And whenever you start that virtual machine, all 3 of those things will start running at once, right? Whereas in Docker containers, we actually set up a network of containers, which are just small, basically isolated processes that are going to run in each their own Docker container, and then we link them up together. So instead of just saying, give me the whole virtual machine up at once, we're going to be starting several different containers. Now, I think if you think about that, it means that on the front end, it's going to be, or at the beginning of your process, it's going to be harder to get set up because you got to start multiple processes rather than just having one virtual machine to get going. But in the long run, it's more flexible because you can sort of spin up extra versions of your Node app or extra versions of your database, or you can switch your database without breaking the whole application flow. So there's some advantages to that as you get going. Yeah, and so these are sort of the big pros. Some of the reason that containers have taken off. It's a lot faster to start a Docker container. How long does it take you guys to start a virtual machine? Anybody have like a good, I don't know, 10, 20 seconds, 30 seconds, a minute? Either way. I mean, like, let's say start one. Let's say you've got it, but you need to start it. 3 minutes, okay, that's a good benchmark. So with Docker containers, you're typically talking like 2 or 3 seconds. So it's a lot faster to get started because they're not rebuilding the whole, from the ground up, the whole operating system. It's just the sort of like top layer of it. They're a lot more portable, and you can kind of share them between different systems easier. We'll kind of see how that linking works in Docker. Because they're sort of, once again, sharing resources, they're more resource efficient, so they take less memory. It's a lot faster to get things updated and changed. One thing that's really handy with Docker is that so unlike a virtual machine where if I wanted to upgrade the version of Node that I was running, I guess we have NVM in Node, so this is less of an exciting advancement. But if you were running something like Ruby, where it's hard to upgrade Ruby, you have to basically rebuild the whole virtual machine to get Ruby running on it, a new version of Ruby. Whereas in Docker containers, we can just pull down a new container for the newest version of Ruby and try our code running inside of it, and we've got a new version running. So we'll see how that works in just a second. The downside is that you've now got to think about security in a slightly different way. And we're not going to this is definitely a pretty entry-level talk. So if you want a Docker security talk, go talk to the Docker Meetup people. They do some more advanced Docker talks, and like that stuff's really great. Especially when you actually want to deploy your containers to production, you're going to want to think about security. And I'll put some like really kind of quick takeaways at the end, but I'm not going to get into detail on that. There's also a little more complexity to get started with Docker. We'll see how that is when we build our first Docker app and we've got 3 or 4 containers running. It's kind of a pain to get going. But there's some tools that make that easier, and we'll get to those too. And then finally, there's a big question mark around production deployments. So there's a lot of people who are like Kubernetes. Have you guys heard of that? Kubernetes is kind of becoming the dominant way to deploy Docker. And so once again, not going to get into that in this talk because there's so much more ground that I can cover that I just got to sort of cut it off somewhere. But if you're going to look into deployments, look into Kubernetes. It's probably your best path forward. And I have some other options I'll show you at the end. All right, any questions on what Docker is? Anything I wasn't clear about? Once again, first time giving this talk, I'm fine repeating stuff, going back to another slide. Yes, sir?
When you say security, again, I'm just trying to understand, what is the con of security? Is it just not, are you just more exposed to this?
Yeah.
Or is it just more things you have to vet to make sure that it's a secure thing?
So what is the deal with security? So I'll stop on this for just a second. When we have our host machine running a host operating system and then a complete guest operating system that's running in isolation from all the other guest operating systems, there's a higher level of security than when all your containers share the same kernel. And basically the problem there is if a Linux kernel vulnerability ever gets into that host system that's hosting Docker, it gets into all your containers potentially. So there's that kind of goes back into like, if you're building your own servers, that's something you have to worry about more than if you're hosting on a platform like an Azure or a S3 where they're going to deal with that stuff for you. So some of that we don't have to worry as much about in managed hosting, but it's still something to think about. And if you hear of vulnerabilities in a kernel, and you're running your container on a kernel, you might know that people could be getting from one container to another through that kernel vulnerability. So once again, I'm not an expert on this Docker security stuff. Some other things though that I will kind of touch on at the end about how you can secure containers before you push into production that might be a little more applied and helpful in our situation. So we'll talk about that. Yes, sir.
You were saying Docker is an isolated process and virtual machine is what?
Yeah, it's like a virtual machine is like running a whole nother computer inside your computer.
Like operating system?
Yeah, like a whole operating system plus all the bins, the users, like everything is in there together. So there's no shared resources, between virtual machines. When you create a virtual machine, you've got to give it a certain amount of your system's resources, and you're stuck with that. Whereas the Docker container is a lot more flexible as far as you want to give one a lot of memory and one a little bit of memory. It's pretty easy to flex that. Cool. All right. So let's build a little Node script. This is going to be like this is the hello world. This is the simplest thing you can do. Even before we do the simplest thing, we're going to do the even simpler thing. So if you wanted to run on your command line, get what version of Node you're running, you would do node-v. Y'all know that one? Okay, good. Yeah, if you've done some JavaScript, hopefully you know that. You can run that same command inside a Docker container using this. So I didn't want to do live coding because I'm not ambitious or brave enough for that. So this is kind of the best that I could do. What we've got are 3 parts of this command, and I kind of highlighted in different colors, although I'll admit the colors are going to be tough to see on the big screen. If you want to, the whole presentation is linked in the meetup, so you can pull that down and you can see the colors well. But basically, the first part of the command is Docker run. This is just telling Docker, hey, you're going to run a container here. We'll talk about what containers are and how we build them in a second, but let's just start with that. Node 9 is saying which image that container is going to be based off of. And so typically it's going to be the process that you want to run, in our case Node, and a version number or a tag number. So Node 9 is saying give me the latest version of Node, version 9. And so it's going to be 9.2 in the case of when I pull this down. I don't know. Node may have updated since then. And then last is the command that the container is actually going to run when it starts. Y'all clear on this? Okay, good. If you can follow this, then we're just going to keep building on this. This is the ground level. Yes, sir? Yeah, one big long command. Yep, this is just, you type this all at once. And if you do see, all these commands are going to be long in the first half of this presentation because I'm not going to use any of the shortcuts with the goal of showing y'all how this works at a granular level. There are ways to make this much faster and easier, and so we'll get to that in a second. So don't worry if you can't follow these. Yes, sir?
So the run command, once you have it installed.
Yeah, once you've got Docker machine installed, so you can go to docker.com, you can go find the latest version for your system. So if it's Mac, there's a Mac version, Windows has a version, and Linux has a version. Technically, it all runs native on Linux. So even if you have the Docker for Mac or Docker for Windows, it's going to have a virtual machine that runs everything that Docker actually has. And I know that that's confusing because we're like, hey, virtual machines are bad, Docker containers are good, and then we have set up virtual machine to run containers in it. Whatever, go read the Stack Overflow arguments about that. That's, once again, this is kind of like, you don't have to worry about that because Docker for Mac or Docker for Windows is going to hide all that away from you. So all you have to know is you went to docker.com, you download the latest version of Docker, it's got a little command line tool, it's going to start working for you. Yes, sir. Yeah, where's the image that Node's based on? I'm glad you asked, because we're going to be addressing that. Let's run a JavaScript file, and I'll get to your question in just a second. So this is a simple hello world JavaScript file. It's going to do a console log, hello world. Y'all get that, right? All right, good.
Can you go over what image means?
Yeah, I will. I'll get to images and where they're stored both in just a second. So thanks for asking. We're definitely going to do that. I'm trying to, build up to this little by little. I know there's a ton, and I'm trying not to throw everything at everybody all at once because it was tough to break this down to simple steps. But Docker run, and then we added a flag here called --rm. This is going to clean up and remove our container after it finishes running. This is one of the I don't know, maybe it's like a vestigial thing hanging around from Docker that when you run a Docker container, by default, it's not going to remove that container after you're done with it. It's going to let you be able to start it back up if you want. So actually, that could be a really good thing. In a lot of cases, though, like when we're running just one script and we want it to die afterwards, we don't want to keep that container around. It's just going to take up space. So typically, when you do a Docker run, you're going to have a --rm. We're going to mount the volume. That's what the -v pwd:/app does. So I'll break this down a little bit because if you're not a command line junkie, then you may not know what $pwd does. What that does is says to the bash shell or whatever that let's give me the full path to the present working directory. That's the way I don't, is that what pwd stands for? That's what I've always said it does because it works, but I don't know if that's technically true. So pwd is present working directory. So what this is saying by saying
print working
-b,
directory.
what is it?
I think it's print working directory.
Print working directory. Justin, so smart. All right, print working directory, which actually makes even more sense because it's actually going to print it and show it. But basically what we're saying here is take the present or print the working directory that we're in and mount it into /app. So going back to the resource isolation that you get with Docker, typically each container does not have any access to your host's file system. So it can't grab files from your host, and that's good because if you give a Docker container the ability to grab any file from your host system, you lose all hope of security, right? But you can mount single directories or paths into that Docker container so that it does have access to the file path you want it to have, which is what we're doing here. So we're just mounting it straight into the /app directory on the container. So that second part after the colon is where it's going in the container. That clear? Kind of clear? And we'll get into what volumes are in a second. I know that's like what the hell's volume? That's all right. We'll get into that. Start there and take my word for it. And then last, what we're doing is running /app/hello.js. So if we had that hello.js file that we created in the last one, this little console log one, in our working directory, then we're going to mount it into /app, and we're going to be able to run it with this command. So this is going to run our hello world. Once again, I know you're like, why am I doing all this extra typing to get hello world? We'll get there in a second, so follow me for a second. Yeah, and so why is this better than NVM? One of the things that's unique about Node compared to a lot of languages is that, how many of you use NVM? I guess I'll stop there. Okay, so not everybody. NVM is awesome. I came from doing more PHP and a little bit of Ruby, and there's not quite as many good tools like NVM out there for them. And so NVM, what it does is Node Version Manager, and it'll let you pick the version of Node you want to run at any time. So you can just switch in your command line in just a few clicks. It's pretty awesome if you need to ever switch between versions of Node. I guess like Docker is really helpful when you can't do that, which happens in production systems where you don't want to run NVM because there may be issues with that. Or if you're, say, working on a machine where you can't just install anything you want, maybe you've got Docker but nothing else. So it's better for those reasons. The other thing that I like about it is that NVM, you're going to have to go to your command line, type some commands to get the latest version or the version node you want, and then it's going to be set until you change it again explicitly. Whereas I could run the same script or several scripts in different Docker containers on different node versions at will. So that means like at runtime I could say, get me node 8, node 9, node 4, whatever, and it's just a lot faster to switch, so that's helpful. It's also really helpful in continuous integration situations where you want to, say, run your code in several different containers with different versions of Node or JavaScript installed at once. That can be helpful if you're maintaining open source library that has to work across multiple instances or machines. And then the other thing that really helps compared to NVM, NVM is not like trying to isolate, it's not a virtual machine, it's not trying to isolate your sort of node path from the rest of your host machine, whereas Docker is, it's completely isolated. So your host machine doesn't know anything about what's running in that container, and or at least to the extent that you care about. And the container doesn't know anything about your host machine other than what you give it. So there's some advantages. Let's talk about volumes before we get into images and image hosting, because this is another sort of tricky point that's a little different than other ways of working. So this is our container. This is straight off the Docker docs. So if you don't get what I tell you, then go read the Docker docs on volumes. It's really good. This is a container, and this whole big outer box is our host machine. So when we start up a container within the host machine, we can choose to mount a volume. And there's several kinds of volumes we can mount. In that last example, what we did is called a bind mount, which means we bind a directory on our host machine to a directory on the Docker container. So it's just one-to-one. And if things change in the container, they're going to change in the host machine. If they change in the host machine, they're going to change in the container. The sort of next kind of volume you can mount is called a true volume, and it's basically a named volume where you tell Docker, here's the name of the volume, and you just store it in your memory, in your little part of the host file system. So underneath Docker, kind of virtualizing your host system away, it actually does have a place in your host hard drive where it stores some stuff, and that's where these named volumes are going to go. Docker can access them slightly faster than the ones that you mount as a bind mount because it doesn't have to keep up with changes on the host system. It makes the changes only one way, so it's a little faster. Quite a bit faster in some situations. It kind of depends what you're doing. And then the final one is a temporary file system mount, and this is like when you want to get a volume that has some temporary data that you want to throw away at the end of the container's life cycle. So this can be for like, if I want to mount a volume with some passwords in it, and then at the end of that Docker container's lifetime, I can just kill it, then we can do it that way. I haven't used this much. Has anybody used temporary file system mounts much? Okay, cool. This is kind of I think it's a newer thing in Docker, and I've gotten in the habit of using environmental variables that you can pass into the containers instead of this. So for me, it hasn't been as useful, but there are cases where this is helpful. So something to look into if you ever find yourself needing to destroy data at the end of a container's lifecycle. Cool, so let's build an actual web application, some really simple Express stuff, and what we're going to try to do here, I guess I'll back up and just say that I'm going to assume you've got Docker installed at this point. I mean, you should have the other commands run. I am going to hope that most of you are at least passingly familiar with Node and Express, and it's great if you know Webpack or at least kind of know how it works. You don't have to get into the inner workings. And all this code is up on GitHub if you want to find it later or follow along. There's also a blog post that I wrote for JavaScript January that's on this exact same topic. That's all linked in these slides at the end. So if you don't get it here, go look at that stuff and hopefully that's more clear. And I'm going to assume that you kind of are okay with running in the CLI a bit. Okay. So this is what we're going to build. It's going to be 3 containers. It's going to have a Postgres database. It's going to have a Node Express app, and it's going to have a front-end container that's going to basically build our style sheets. So it's going to take some SCSS files and build them into CSS files. So pretty simple stack. And it's just going to be a list of colleges. It's not much really interesting, but just something to get you kind of like thinking. Let's start with the very first part of this, the Node app. So if you want to follow along, you can clone this repository. And then you can navigate to it, and you can check out a branch called Start Here. If you want to just follow step by step, that's basically what I'm going to do, is start with that Start Here branch and just work our way through it. So you can do out later if you're doing this at home. So I kind of talked about volumes and bind mounts between your host file system and the container. And that's great, but in a lot of cases, what we need to do is build our dependencies within the actual container that we'll be running our code. So how many of you have ever, like say in a virtual machine, did an npm install and then tried to use that same node modules folder in your host machine that's a Mac? Has anybody tried that and like broken things? Maybe nobody's adventurous. Yeah, okay. So if you install your node modules on a machine that is different from your actual machine you're going to run the app on, you're going to run into problems. It has to do with how a lot of node modules are built. And so what we want to do when we build our Docker containers, or when we sort of create a Docker container or run it, before that, we want to actually build an image. And so for you two gentlemen who asked about the images, this will be your jam. So this is the process that we go through with getting to an actual container. So far, what I've been doing is kind of starting us off at the Docker run phase because it's kind of the simplest to get started and actually build something. But in reality, what happens is someone somewhere on the internet defined a Docker file. And that Docker file is like a big configuration with all the steps of everything that needs to run in order to get this image created. So we're going to say Docker build, and we're going to specify a Docker file, and it's going to create an image for us. And that image is going to live out there in a repository. And anytime we want to run a container, we'll run it from that image. Anybody with me? Anybody have questions on this before I keep going? Yeah, so Docker Hub is where you find images. And someone behind the scenes built those images from a Docker file. A lot of times you don't even know what the Docker file was, or you don't care really, as long as the image does what you need it to. So it has, in our case, like Node 9 installed. If you're running in like a production environment, it might be a good idea to check that image is actually like safe, secure, and ready for production runs. So if you're getting like a unofficial image from some guy's GitHub account or his Docker Hub account, maybe double check to make sure it's not completely stealing your data as it's building the containers or something. Yeah. Yes, sir.
Does Docker support versioning the same image for production when you have like one application for two different clients?
Yes, good question. So Docker has a system called tagging images. And when you tag an image, you're tagging it to like either usually it's a version. So a lot of times people will tag the sort of most recent one as latest. That's kind of a common convention. It's like the most recent, sometimes not stable version of the image that we're building on. So you might have a node latest, node : latest, and that's going to be the latest version of Node, regardless of, might be, if they upgrade to 10 tomorrow, it'll be 10 tomorrow. So you got to be careful of that. If you want to build specifically named images, you can use those tags to name one like Node 8, and that's going to be locked at Node 8. So that's kind of the way to indicate. And when you're building in a sort of production environment, you want to deploy those containers, then you definitely want to tag your images so that you know what's running on each server. Yeah. And that does kind of get into a little more, like, I would read the Docker docs on that because I'm not giving a full explanation, but that's a good starting point to how to think about it. Anybody have questions on images, building images from Docker files? We're going to do one in a second. And I'm not going to, so this is what a Docker file looks like. You can get this from the GitHub repository. I know this is tiny, so I don't expect you to read it. That's kind of I'm just going to tell you what it does. You can get it from the GitHub repository and look at each line. There's comments in it so that you can kind of see what each line is doing. But at a high level, what we do is use a base node image as our starting point. And we use a keyword called from and then node 9. So that means our image is going to be built on the node 9 image. What's really cool about this is like you can go out there to Docker Hub and find starting points, just images out there that do all sorts of cool things or have all sorts of software already installed on. And you can then build from there to get yourself to where you need to be for your actual application. So kind of like, when we build stuff off of packages, this is sort of the server or environmental version of doing that. And then what we're going to do inside of this Docker file is add our code. We're going to install the npm modules or dependencies, and we're going to set a default command that's going to run when this container runs. You don't have to do that. That's optional. You can also do it at the Docker run stage like we did in the earlier ones, but it kind of saves you a little time. In this case, we're running, I think we're going to run nodemon, which is, have you all used nodemon? It's a node process manager. It just keeps like node running, and it'll restart it when your code changes. So if you're building Express apps, it's really helpful to quickly get stuff changed just in dev environments, don't run in production. And then there's also a thing called a Docker ignore file. Once again, I'm not going to go into super deep detail here, but I'm just going to tell you, like a git ignore file, it's telling Docker, don't put these things in the image that you're building. A lot of times what people do is they'll build a Docker image and then push it to a repository where other people on the team can get access to that image. And we don't necessarily want things like a Git history in a Docker image. It's not really helpful because people can't download that image and like actually go do work in it, or they shouldn't be. They also, probably don't need our local version of the node modules. That's what is being ignored here. And then things like DS store, or if you have data stored in your project directory, stuff like that, you want to ignore. So let's build an image from a Docker file. So before I was saying that sort of when we have the 3 steps, you start with a Docker file, you do Docker build and then some stuff, and you get an image. And then you're going to say Docker run with the name of the image to get a container. So this is the step going from a Docker file to an actual Docker image. And we did a couple things here. Docker build is the command that's going to tell Docker we're creating a new image. -t node Docker is basically tagging our image with a name. We can also tag it with a version at the end so that there's like a :latest if we wanted to be more precise. In this case, because I'm used to using this for local development, I didn't worry about that. And then finally, there's a little dot at the end. So don't miss that, because that's telling Docker, when you build this image, the context is dot, which is the present working directory as well. So basically saying that the image that you're going to build is based around this current folder that I've navigated to in my command line. So we've got our image, and we've got it tagged with something. Now let's actually run it. And this one is basically just doing a little more from what we did earlier. In the app that we're running, there's kind of 2 places where code lives. There's an app directory and a public directory, so I'm mounting both of those as volumes. And then I'm doing one other thing that's new, and that's I'm setting a -p 3000 3000. So what this does is it tells Docker, when you run this container, open up port 3000 on the container to map it to my host machine's port 3000. So now when we run this, the node process is going to run in the Docker container on port 3000, and it's going to link to our local host port 3000. So now we can see everything in it on our local host as well. And then finally, node Docker is the image that we just created. That's what we tagged it as our name. So that's what's happening there. Y'all with me? I haven't lost too many people yet. It can be anything. Yeah, descriptive names are helpful, so I use node Docker. But yeah, whatever you want to name it. Yes, sir.
So that last P part, it opens your container for 3000 with your machine.
Yeah, maps it is what they call it with your local machines. Yep. So typically when you run a node app somewhere in our configuration or app file, we said this node app's going to run on port 3000, and so that's in the code. And I didn't want to get into too much nitty gritty of the code, but basically, since the app is running on port 3000 in the container, we have to somehow get our local host to know that that's there. Because once again, for like the purposes of isolation, we don't necessarily want our Docker container to have access at will to any of our host machine's ports, right? So we need to explicitly map those out. And this is what you're going to see when you put this up. It's just, like a simple home page, and there's a link to colleges, which won't actually work yet because we don't have a database. And then you can stop the container with Control-C on Mac. I can't remember what it is on Windows, but basically it's the same command you use in Bash to or the shell to stop whatever you're doing, stop the process. We'll get into other ways to stop containers in a second, but kind of start there. All right, so let's build a database. Normally, this is where I think Docker really starts to shine, because we have a node version manager, which is nice for running multiple versions of Node and actually is helpful. But if I want to run multiple versions of a database like Postgres, it's really hard. Has anyone ever set that up on their local machine to run like multiple versions of MySQL or Postgres or something? Like, yeah, I used to do that, and I was a sucker, I think. It's really tough because you have to run them each on different ports or do some kind of mapping so that you don't get them overlapping each other. And if you connect to the wrong one, you cause yourself trouble. And so that's kind of the typical path you're installing locally or installing multiple versions of Postgres on a virtual machine, same idea. With Docker, what you can do is start a completely isolated Postgres container that opens up whatever port you want to map it to on your host machine, and it can just shut down at the end when you're done running it and you don't want connected to anything else. You can also link explicitly containers that you want to have access to that database container as it's running. So that way, when you're running, say, multiple projects at once in many different containers, only the projects that are supposed to have access to your database can actually link to it. So you set that link up explicitly. And we'll get into exactly how that works in a second. So this is if any of y'all ever use Sequelize, I use that as my ORM sort of here. It's just a really simple way to connect to a Postgres database and then grab stuff. So there's models. If you haven't used it, that's fine. It's basically just, we're going to create a database table called public colleges, and it's going to have an ID, a name, a created at, and an updated at, timestamp. And then we're also going to have a seed file that's going to just insert some dummy data into that database. So this is these are poor man's migrations and seeds. You probably want to use an actual library that did real migrations and seeds if you're doing a big project, but I wasn't concerned with that for this. So there's a few things we're going to do here. We're going to run the database container. We're going to then run our migration SQL file, and then we're going to run our seed SQL file. So I'll start off with just running the database container, because that's kind of the first step in all this. The things that are new here, I'm kind of doing this one in two parts, so you can ignore this bottom half. First thing I did is added a -d flag. So before, when I ran my Docker container, it was running sort of attached to my current bash shell, so I couldn't with the -d, I'm running in detached mode, meaning it's running in the background and I don't have to be connected to it and stopping it. I can't stop it with Control-C anymore. We'll get into how to stop that in a second. And then I'm going to map my port, so 5432 to 5432 on my local machine. If you're already running Postgres locally, the great thing is you can just map a different port to your local machine, so 5433 or 35, or you add a 0 at the end, whatever you want. And that's fine. And then your local machine will be able to connect to Postgres on that port, so you can run whatever database management software you want to check out what's going on. And then finally, I'm setting -e, which is an environmental variable, for Postgres user to be admin. Now, if you're running a container anywhere where you might be shared with people, you should probably set not only a user, but also a password. I'm not doing it just because this is for the purpose of local host and the meetup, so it's just one more command. It wouldn't fit on here very well. But you can do that in the real world, and you should do that. So Postgres, when you look at the Postgres database image, yes, sir? Yeah, so we'll get into Compose in a second, because Compose is awesome and it's going to save us a lot of trouble. And I've been typing out these big long commands, and you guys are like, I'm never going to remember this. Docker is useless. But in a second, when we get to Docker Compose, it will sort of answer all your problems and make it a lot easier. You can sort of dynamically set these ports as you're kind of getting to, and you don't even have to open up this Postgres container to a port on your host machine if you don't want. So I did this because a lot of times I use DataGrip to connect to the database just to check out what's going on, make sure nothing's funky in the database after I run it. But you don't have to do that. If you want, you could basically exec right into that container and run SQL statements on it. So you don't have to map it to a local system port. In the second part of this, I'm actually doing something here where I'm mounting a .data directory into Postgres's actual, where it stores data. So that way, when the container shuts down, I still have the data locally, and it's actually right there in that project. This is something I've been doing for a while, and I think maybe best practices in Docker have started to move away from it, so I would look into doing named volumes. That seems to be the way that they're pushing people. But this used to be sort of the best way to keep your data persisting between container shutdowns. So when you think about it, this container runs up and it's going to do some stuff, and then when you say stop the container, it's going to die and all the data that was in it is gone. So if you're running databases in containers, know where your data lives and know how to map it somewhere that you can save it. And if this is going over your head, there's a good section in the Postgres database image on Docker Hub. So Docker Hub, look for Postgres, you'll find it. It tells you a little more about how this works and where you should mount that data. And this is also a reason that a lot of people don't run containers to actually run their databases. They'll run their databases in containers. They'll actually run like with a managed service instead, like a RDS or whatever. And so you can do that. That's definitely a good option. I'm also mounting in the SQL directory, which is where I had my migration and my seed files. So I'm going to run those in that container later, so I'm just going to mount that data. And then the last one is I'm naming that database container NDDB. And there's no convention or reason for that name other than I chose it once, and now it's that. So that way I've got a name for my container, and that way I can reference it from other containers. We'll get to that in just a second. First, though, let's talk about how we run a migration within an existing container. So at this point, the container is up and running, the database is up and running, and we could access it from our local host at port 5432 or whatever. And that's one way to do it. We could like just access it from our local host, connect with the database manager, and run these scripts manually. That's one option. The other option is you run Docker exec, the name of the container, and then the command you want to run. So if you don't know Postgres, this is just a big command that's going to say, it like forces Postgres to run this file as a SQL command. So if you're not good at SQL, that's fine. Just trust me, this basically creates your database tables. And what Docker exec does is it's a lot like Docker run, except it's running on, it's going to sort of, I guess it's basically spinning up another version of that exact same container that is already running and running the command. So it's like we get one little quick process out of this new container, and then it's shut down. We do this again for the seeds file, basically the exact same thing, we're just doing it on the seeds. Y'all clear on this? Anybody have questions on sort of getting into that database container, running a seed migration? Yes, sir.
Docker exec, it runs the command inside of already running Docker that you have. Is that what you're saying?
Yeah, so it looks like it's running it within a currently running container. But, so for all practical purposes, yes, that's what it's doing. In reality, though, if anybody knows this for sure, I was listening to some podcasts where they were talking about how it actually works, and it really is spinning up like an identical container. And the reason for that is that each container only gets one process. So by connecting to it like with a shell command, you can't really do that because the container's running one process already. It's running Postgres already. So it's a little more complicated in reality, but in practice for us at the like dev level, this is essentially SSHing into your container. And Docker people don't like that because it's not, but it is for like simple node developers. So like myself. So that's how we do that. Now, if we want to run our code and connect to that database, the only thing we have to change from what we did before is -- link NDDB, and then I also added the D flag so it's in detached mode as well. So now, I think the next slide is showing it working with data. So now there's some data, and this is how it looks. Hopefully, if you're following along, this is how it looks as well. Cool, so that's how simple it is to basically spin up this node container and connect it to the Postgres container. That said, there's a lot of typing there, or copying and pasting, if you're like following along and trying to go through the slides, and that kind of sucks. We'll get to how to fix that in a second. I'll just go over a couple commands that are really useful if you run into problems throughout this process. There's two things you'll want to know. One is Docker PS, which is like show all the containers. It's like list them out for me. This is all the currently running ones. You can add a -A flag to show the ones that have stopped but are not destroyed. You can add a bunch of other flags if you want to, and you'll have to look at the docs for how to do that. There's also a Docker logs command if you need to look at the actual logs or tail the logs from a container. Another one to look at the docs for. And then you can stop those containers by saying Docker stop and then the name of as many containers as you want with spaces between them. So that's to like shut down your app essentially. Okay, so we did all this stuff and this is cool, but this is also like nobody's going to do this. This is a huge pain, and I recognize that, and I would never have stuck with Docker if this were the end of this talk, because it's just way too hard to do all those command line things. So what Docker Compose does is it takes all those big long commands that we ran in our shell, our bash scripts we ran, and it puts them into a text file, a YAML file, and then lets us say Docker Compose up, and the whole thing is running. So before we were doing Docker run ...
Now we're just doing Docker Compose up, and it's going. All the containers that we want to start at once can all start at once. The links are all set up. It's really like magic if you've been doing Docker the hard way. The big plus is that you can check that Docker Compose file into version control. So now anytime anyone on your team grabs your latest version of your repository, they're going to have access to that Docker Compose file. That means they're going to be able to set up immediately all their containers to run exactly the same way you did. So really powerful there. I think one of the challenges I've always had with virtual machines, and I know there are some solutions, but like is sharing those virtual machines with other people around either like locally and sharing them securely. So I'm not like just checking in all my environmental variables or something crazy. And you can do this really easy with Docker Compose files. It's also, I mean, it's just much easier. The downside is, and the reason I talk about the actual Docker commands first, is that it's an abstraction layer, so we're missing what's actually happening. And if you don't understand what's actually happening when you say Docker Compose up, you run a risk of having these containers hanging around and running, and you not knowing why, one won't shut down or it won't let you connect to something. And so starting with a little bit of the primer there is, I think, important. And so if you're running quick scripts, you can do Docker run, that's fine. If you're going to run a real application, Docker Compose is almost always what you want to do. And so this is what a Docker Compose file looks like. This is kind of like, this is one file. I just split it down the middle to make it easier to see on one screen. This side is dealing with the node container that we were running, and this side is the Postgres database container. So a lot of these commands, or the sort of preferences in the Docker Compose file, are very similar to what we ran at the command line. So that's helpful. You can even specify like the build directory. So it actually, Docker Compose will also do a Docker build as well as doing an actual Docker run. So all in one command. And so it's really easy to like build and run a whole system. You can tell it what volumes to mount, the ports to map, and the links to other containers that are going to run. And that's going to automatically set up all these containers. There's a ton of options with Docker Compose files. Once again, check the docs. I'm not going into all of them here. Y'all with me on this? Yes?
So when you're creating volumes, those are directories that you're creating within your Docker that you want to interact with?
Yeah, it's like, it's a mapping between a directory on my host file or on my host machine and in the Docker container. So I want to have that file in both places. So it's great for example, code. Like I want to change the code on my host machine because that's where my IDE lives or my text editor lives. And it needs to be reflected immediately in that Docker container as it's running. So for local development, that's how you want to like use volume. Now, when you're in production, obviously you don't want your code living in a volume because you want it to be isolated. That's like a big pro to Docker. So you wouldn't mount those same volumes. And so when you write a Docker Compose file, usually you're going to have one for each environment. And you probably won't use Docker Compose for a production environment because there's better tools for like scalability. But regardless, if you wanted, you could run an app in production on Docker Compose. It would work. But you wouldn't want to mount those volumes in the same way. Yeah. Any other questions on Docker Compose before I'm going to show a little more of it, but happy to. Yes, sir. Yeah, so Vagrant and Packer, right, are the tools that basically let you do similar stuff with virtual machines. Isn't that right? Like it's like share environments and stuff. And I have used those, and they're good too. I think that once again, it kind of goes back to those pros and cons of containers versus virtual machines. There's some things that are good about containers. They're faster and lighter weight. There's some things that are not quite so good. They're newer and kind of harder to manage at first. So, yeah. Yeah, that's right. So when you say, in this next sort of slide, we're going to say Docker Compose up. And what that's going to do is see if the container is built already. If it is, then it's going to go ahead and run it. If it's not, it's going to build the container first based on this directory. So it's going to look at the current directory and say, is there a Docker file here? If so, let's build an image off of it. And then it's going to run the container with all these preferences, including the volumes, which say, mount the app directory on my local machine right here to the src/app on the Docker container that runs. And if there isn't a directory there on my machine, it's going to create it. Same with if there's not one on the Docker container, it's going to create it as well. Cool. So yeah, we can run those containers. And if we do Docker Compose up without the D flag, it's just going to like be running live and we'll tail the logs in our actual shell or whatever. So that's usually you want to do detached mode, but sometimes you don't. Sometimes you just quickly want to have it running and see the logs. And then you can run Docker compose down to stop the whole thing and kill all your containers. And removes them automatically as well. You can also do Docker compose stop if you do want to just stop those containers and not actually destroy them. So if you don't mount your data in a volume and you realize that, you can say Docker compose stop and then figure out some way to, I don't know if you can mount a volume when you restart it. I'm not sure about that. Maybe something to try if you're desperate. Yeah. So let's add a front end. I am really, every time I set up a Webpack system, I'm more of a backend person. So every time I set up Webpack, it takes me way longer than I'd like to admit. I don't know if I'm alone in that or if Webpack's just hard to do, but it seems like, I don't set up many front-end projects, and so every 6 months to a year when I do, it has changed, or there's a major version release that has broken the way I used to do it. And so I did eventually get Webpack working, and it's in a branch called adding-frontend if you want to look at that. But basically what happens in our really simple Webpack setup is all this. We just, I added some loaders as dev dependencies, and then I added the config file and entry point file. I added a SCSS style sheet instead of having the CSS style sheet, and then there's like a Webpack process to just build the CSS and then put it goes into the front end file, the layout file or whatever for handlebars. So anyway, if you're good at front end, that'll make a lot of sense. If you're not, don't even trust my way of doing it because I'm not that good at it. But if you do want to run a Webpack instance in a Docker container, you can definitely and probably should do that if you're going to go Docker, go all the way. So when you want to run Node or Webpack without Docker, here's what I would typically do. I like running the local version of Webpack. Once again, it goes down to like those version things. I don't know if there's other cons to that. Is anybody like good at Webpack knows this? Like, is there a problem with running Webpack out of Node modules and stuff globally? They always say to do it globally, but I'm never sure why. Okay. Look at what? Yeah. Okay. All right. Gotcha. That way, right. So that way you're not, typing out 5 things. And actually, you bring up a really good point. With a lot of these Docker commands, when they get to be too long and painful, I'll write like npm scripts in my package JSON file that run them. That's kind of my shortcut, but you can come up with your own batch scripts work too. So with Docker, we would do it this way, but we're not going to run this individually like we did before. We're going to do this in Docker Compose. So I'm going to add a couple things here to my Docker file. One is I'm going to make sure that we install our dev dependencies when we install the packages in the Docker file, and I'm going to run or add the application code, which is like for the front end, so the SCSS file. And then I'm going to copy the Webpack config, make sure that gets into the container as well. And then the last thing I'm going to do is add a little bit in the Docker Compose file about the front end, and this just says build it from the current directory, mount a volume of the code for the front end, and then this is the command you're going to run when the container runs. So that goes into the Docker Compose file. And now when I, say, change some styling, and I didn't do like a automatic refresh kind of thing, although I think you can set that up. So I think here I'm just going to edit text size, like type to something large. I'm going to refresh, and it's like automatically happening. This is on that side's running in a container, and you can see the logs kind of tailing down there, and this side's running localhost 3000. So that's what you should get to if you follow along with this. Any questions? Anyone want to see anything more? Yes?
Compose files are YAML files?
Yes. Yep. Compose files are YAML files. Correct.
You call the Docker compose, you have to specify.
That's correct. If you name it docker-compose.yml, you don't have to specify the name of the file because Docker automatically looks for that. If you want to run multiple Docker Compose files or have like 3 or 4 in your root directory or maybe a subdirectory, you definitely want to specify, and there's a flag for Docker Compose like -f, I think, is for files. And so you can specify a specific Docker file or Docker Compose file. Sorry. Anybody else? Questions on this stuff? Okay. So what's next? Some people ask some questions, and if you're like, if this was really boring because you've done Docker a bunch, I'm sorry that you had to sit through this. You should have left because that was not my intent. But this part will actually be interesting for you. So some things you can get into next. if you're just going to work on local dev, which might be, I think is a really good way to start using Docker. Like I kind of challenged myself at the beginning of last year and said, I'm just not going to install any actual, like any processes that I normally would. So no PHP, no MySQL, no Ruby or whatever. I'm just going to run everything in containers. And doing that has been really helpful for forcing myself to learn. And some of the things that, you kind of get into next as next steps are, you got to manage environmental variables some way, somehow, and there's a couple ways you can do it in Docker. You need to figure out how to sort of run tests within Docker containers, and then maybe even hook those up to a port in your IDE so you can do like step debugging. It's really cool if you can set that up. I've seen people set it up. I have not taken the time to do it myself, I'll admit. But I do use, containers are really helpful for running like your test suite in multiple versions of a sort of system. So that's really helpful there. And then typically, like you'll want to run your Node app behind an Nginx container as well. And so there's a web server container you'd go into next. And then you may want to push that image, the Docker image you've been building locally, to a repository so that you can pull it down and run it on the server or share it with another person who can run it on their machine instantly. And so that's the next thing you can kind of look into. A couple things to mention before you run on an actual server. So production sort of level images, there's a whole bunch of checklists out there. I think I linked to one at the end of this. It's kind of like node checklist for a node checklist for production images. So go look at that. Other people have better things to say than I would. And then the other thing you need to think about a lot is how you're going to do the databases. You can run databases in production on Docker. You'll hear people say you can't, or it's hard, or it's bad, or something. I don't think that's necessarily true. You just have to think about where that data ultimately lives. And if you run multiple containers of your database, how are you going to deal with the sort of shared volume that they're all going to have, and what's going to happen if there's runtime conflicts and stuff like that. That's kind of a whole other issue. But if you can run all your database in one single container, it's actually not that hard. Typically if you're running in production, you don't want to have your root user running in your containers, because most containers or most images run off the root user by default, just to make it easier. That root user isn't necessarily able to access your host or your local system's root stuff, but it also might have more access within that container than you'd like. So something to sort of plan for. And then how are you going to keep these containers running, and how are you going to sort of scale them out as you add more servers and want to pop in more instances of your containers? That's something to think about. And the key word to look for there is orchestration, and that's where Kubernetes comes in, and there's 3 or 4 other tools, Rancher, Docker Compose, which has a branch called Docker Swarm that basically does the same thing. So all that stuff is good to look into. And then another thing people ask me about, so I have sort of 3 tiers of things you can do to host a container. The simplest way to do it is to use a specialized service that is for hosting containers. So I like hyper.sh, and it basically just sort of instead of saying Docker run whatever, I can say hyper run whatever, and it'll run that exact same container and keep it running out on a virtual machine somewhere in space. The nice thing for the side projects and stuff, it's really cheap and it's really easy to get stuff put out there. I wouldn't probably use it for a larger real company project at this point, because I think they're still a little unstable, and I haven't had as great uptime as I'd like, but it works. And then the big 3 all have 3 or 4 different ways you can host containers, so you can go read them, all their docs if you like. And then the last sort of most work, but also most flexibility, is just bring your own virtual machines. So whoever your host is, or if you have bare metal servers at your office, you can just install Docker directly on there. That'll work too. And I think that's it. There's some further reading here. I wrote there's a blog post on this topic on JavaScript January. The code for this is on GitHub. I have a blog that's mostly PHP and Docker stuff, and there's a free book on there called shipphp.com. And then there's this Docker security book is free, and that's going to get you into sort of some production level security stuff you want to think about. I actually haven't read it yet, but I've heard it's good, and it's been on my reading list, so I'll be doing that in the next year or 2. Awesome, thanks so much. I'm on Twitter, and if anybody has questions, I'm going to hang around. I know this is kind of long anyway, but I really appreciate everybody's time. Thank you so much. Yeah. Yeah, on Meetup, I left a comment down there with like a link to this whole thing. And so yeah, it should be publicly accessible. If I didn't set permissions right, tell me.
No, yeah, I can.
Okay, cool. You can exit. All right. I at least let John pour it out. Yes, sir.
If you want to run data, store data in your containers, you put them in volumes, right?
Typically, yeah. And that kind of, I would go read the Docker docs on the kinds of volumes and what they're good and bad for. Probably you're going to use a named volume for data for a database, and that is going to give you the speed of its running within Docker's world, but the sort of like it's going to stick around after Docker's container stops. So even if your database container dies, that volume still lives in Docker's world. Yes, sir. The complexity to get things going, like when you have to get a bunch of containers going. So, for example, we run on like, Rob, how many is it? 6 or 7 microservices? Yeah. And so with a 2-person team running 6 or 7 services, and each of them have their own database and their own web server and all this stuff. Like, even we've got several Docker compose files and lots of things there. But even so, there's issues. Like it probably still took a day to get you up and running on it, and it's still kind of a pain because there's no silver bullet for that problem of like we want to run a bunch of systems. Because virtual machines would have the problem of each like this thing's going to be huge in memory sensitive, so there's downsides there too. So I think that sort of that initial curve of getting into Docker is pretty high, and that's maybe where people have the most struggle. Docker Compose was what put it over the edge for me. That was where I was like, oh, okay, so I can just write one compose file, and it spins up all my services at once. That's, that takes the cake. It just makes it doable. Yeah. Yes, sir.
Local development, you use like uploading those on the other
Oh yeah, so I wasn't actually using auto reload. I was just using Webpack's watch flag so that it would automatically rebuild, and then I just went and clicked refresh. You can set up the auto reload though. I struggled with Webpack long enough and was sick of it. So people who are good with Webpack, you can make a pull request on that open source repository and get it working. I would love that. Oh, yeah. The Docker Compose files, yeah. Right, yeah. That's a good question. So in the Docker file, you can say that, like, I want to expose certain ports. You don't actually map them in the Docker file. You map them in the Docker Compose file. So you think about, like, that container is one process, and that you want to give that process as limited a scope to, like, do things like open up ports as possible, right? So if I'm building a Docker image from a Docker file, I feel like I'm getting recorded. So if I'm building a Docker image from a Docker file, I don't want to give that Docker container that's going to run access to every port if it, if the person wants to bind it. I only want to give it access to, like, say, the port 3000 in the node case, or port 5432, or some range of ports maybe. So you can specify those things in your Docker file. And then in Docker Compose, when you try to map those ports to the host machine, it's only going to let you map the ones that are allowed to be mapped. So it's just another layer of security. And so if you think about it in a production world, like if I'm creating a Docker image that's going to run in production, I don't want someone to be able to map any port willy-nilly. I want it to be like only the ports I know what they do and that I'm like having control over. Yeah. Yeah. So you can specify mount points in the Docker image, the Docker file, but you can't actually mount the code in that Docker file because the Docker file is just a specification for the image. And then in the Docker Compose file, you can actually mount the volumes, but you mount them to specified mount points. So there's a whole read the docs on that for sure because like. I'm not an expert in that stuff. A lot of times I'm just using what the default mount points are for stuff. It's easiest and it's mostly what you have to do. But it's something good to look into if you're going to create your custom images from the ground up or something. Anybody else? Cool. Awesome. Well, I'll hang around up here if anybody wants to come up. But thanks.
Great. Thanks for coming out, everybody. I think the next meetup is set for March 20th.
Yeah.
Yeah. It is going to be here? Okay, cool. And I believe we're still looking for a topic?
Yeah, we have to.
Okay, we've got some proposals, but we're always looking for more stuff. Or if there's things you want to learn about, you want to hear about, let us know so we can kind of ask around for that. All right? Good night.
If anyone doesn't know how to get out of here, go that way. Look at Jono right there in the Innova shirt. Follow the exit signs. We'll take you to the reception, and then that's the door to get out to the elevator. Thank you.